this is about circuit breaker testing. We are going to test this low voltage circuit breaker, and this small circuit breaker is intended for heavy load but low voltage. Okay, you can look at the characteristics plate on the screen. You see that this breaker has two protection elements. One of those is the thermal sensitivity, which is now set up to 125 amperes, which means that any current below 125 amperes will not produce any tripping, okay, no matter how long it is. But after that current, the tripping mechanism in the circuit breaker will start to operate, okay, and it will start to time, searching for a thermal overload. Okay, so if the current exceeds this value, it will start timing before producing an interruption on the circuit. Okay, and there is also a magnetic element which is set up to 875 amperes. You can see there it has a tolerance plus minus 20%, which means that any current above this limit will produce an immediate trip. Okay, it will be considered as short circuit or very high dangerous current, so the circuit breaker should trip immediately. And this is what we are going to test. Okay, the thermal and the magnetic protection characteristics on this breaker. This is a simple graphic representation of these characteristics. And I am showing here the collection of points that we are going to test. This is just a collection of current values. Okay, we are going to test the circuit breaker under 300 ampere, 500 ampere, 800 ampere, and 900 ampere. If you wish, we can add more test points. Okay, no problem. I will show you how much current are we able to inject in the conditions that we have here in this office right now. The Raptor system is a modular product. Okay, the master unit here is the main product that we have here right now on the table. I will show it to you. Okay, so you can see the live setup that we have for this testing. I will point to you the elements here. So we have the Raptor system here. This is just a simple master unit. This has output power of 3 kilovolt ampere. This is the connection to the command unit that is here. Okay, this is a long cable to connect to the injection device, which is this. And we have the injection cable. Okay, in this case we are doing an additional turn around the unit to produce a higher voltage. Okay, I will let you know why a little bit later. So and these are the connections to one of the phases of the circuit breaker. Okay, the Raptor system is a single phase system, although we can also build a three-phase version by using 3 of these units. Okay, 3 master units can configure a three-phase system. So this is the command unit. Okay, we are going to use it, and we are going to see it on the screen also, and that's why I have connected this unit, okay, with all the menus and all the control interface. I have connected it to the network in order to produce a graphic replication on the screen so you can see it during the testing. Okay, this is the circuit breaker, and these are the current connections, okay, to both sides of one of the phases. This small camera here will provide you with a closer look at this. I will show it to you right now. Okay, so you hopefully you will be able to see when the circuit breaker moves this handle, okay, when it trips. All right, so now the circuit breaker is closed. Okay, so it's ready to receive some current injection. here, right? This is the master unit we are using now. And there are a number of options and accessories that you can complement your Raptor system with. Okay, for example, a high voltage converter if you need to test anything up to 2 kilovolts. Okay, or high current amplifiers, which we call slave units. Each of these amplifiers adds 5 kilovolt ampere power to the system. Okay, so when you have a long impedance, so you need very, very long cables to connect to the receiver of your testing, the element that you are testing, whichever it is. It might be a circuit breaker, a bus bar, a transformer, or whatever. Okay, when you need long cables, you will possibly need an additional current amplifying unit like this one here. This is the special commander for the 3-phase Raptor. Okay, transport case that you can also see here. The extra flexible cables that we recommend for the Raptor, because they allow you to do the multi-turn feature as we are using in this example today, and a small probe that will let you very quickly check the polarity, the connections in any installation, in any AC installation. With the Raptor injecting a codified signal, this small probe will show you with a green or a red LED here, and a beep, an audible beep, if a connection is the wrong polarity. So this is what we are going to use today, just a master unit with a commander and a 3-meter cable that we have on the table right now. Well, this is a brief description how what's the main elements in the master unit. Okay, you have the high current output hole here. We use the induction method to produce high current, so you save some connections. You don't need to connect cables to the unit. Just insert the cable inside the unit and come from the other side to both sides to the machine that you are testing. Okay, there is also an auxiliary output for low current but higher voltage. Okay, up to 200 volts here. It's useful for applications like, for example, determining the saturation voltage in a current transformer. Okay, this is what we use for that. Okay. And on the other side of the unit, you have a number of measurement inputs. For example, a voltage input here, an ammeter here, and extremely sensitive voltage input here for some millivolt sensitivity. We are going to use it today so that you learn how to measure also the contact resistance in this circuit breaker. Okay, so this is basically what we are going to do. Okay, we are going to use the thick cable to inject current in one of the phases of the breaker until it trips. This diagram is exactly the same diagram you get in the commander when you select the circuit breaker testing template. I will show the commander right now on the screen for you, and I will show you the template and also this diagram. Okay, so here on the right of your screen you can see the Raptor commander. I can partially operate it from my computer. From the using my mouse and my keyboard. I can select the different digits of adjustment. Okay, I can also click on the menu to select different options on the interface and so on. So now I'm selecting one of the test template, which is the contact resistance template. I will show you here. So you see there's a template named AC resistance, and this is the template we are going to use to check the contact resistance in the connected phase of the circuit breaker here. Okay, so you see we have the current connections already made. We only need to add the voltage connections. Okay, so we are just taking this cable from here, from the high sensitivity voltage input here. Take this cable and connect the voltage measurement terminals to each side of the phase. That's it. And now select one amount of current on the commander here. Okay, I just adjust, for example, 100 amp. Okay, enable the output and start. So you can see that the Raptor is injecting 100 ampere right now across this phase in the circuit breaker, which is closed, and stops the test, giving me a reading. What's the impedance on this connection? Okay, in this connection, I have an impedance of 519 micro ohms. All right. So if we take this impedance value and go to the current calculator, also in the included in the Raptor interface, we go to the menu, select the calculator, and enter this impedance here. Okay, this is 519. We enter the type of cable that we have, which is a 120 square millimeter section. We just have one cable. This is 3 meters long, and we are doing 2 turns. So you see, according to the calculator, I am able to inject this amount of current across this pole in the circuit breaker. Okay. Of course, this is only valid if the supply voltage is steadily supplying 230 volts, as I have entered here. Okay, if my voltage input comes down to 120, I have to recalculate. Okay, this is slightly less current. Okay, so it depends on this power supply, of course, right? So let's exit the calculator, go back to the template area. Okay, this was the contact resistance template, but now I am going to select the test template for this exercise today, which is the circuit breaker template. If I enter the options section and click on the connection diagram, you will see exactly the same diagram that I was showing you in the presentation. Okay, so I exit the diagram picture and coming back to the interface, you see I have a flashing here reminding me that I am starting a test session, so I might need to have the Raptor calibrate the connected load. Okay, this is important, especially for the tests that take a very short duration. It is important that the Raptor pre-calibrates the load in order to inject the selected amount of current from the very beginning. Okay, so I am just entering a small amount of current, for example 100 ampere, enable the output and activate just for a short while. Okay, now you see it's disappeared, the orange indicator here. Also it's asking me to confirm that it's 2 turns what I have made in around the unit, okay, around the unit here. So I will just confirm it. And now I am ready to test. The first point we are going to test is 300 ampere. I enter 300 ampere, enable the output, and start. So you see the chronometer is now running here, okay? From the very beginning of the test, it starts running. It will be slightly long because at 300 ampere, we are in the very beginning of the curve. So it will take quite a few number of seconds before tripping. You will see the tripping here, okay? And you will hear the noise of tripping as well. Okay, so we have a trip here at 66 seconds, right? It's very typical that this trip time goes down when I repeat the test, okay? Because in the very first test, the breaker is cold, which is not the normal operating situation, okay? Normally, a circuit breaker in operation has a temperature, okay? So the thermal element is, of course, sensitive to the initial value of temperature in the internal conductors, okay? So we are going to repeat this test, and you will see how this time decreases a little bit. We close the breaker again and just press on again. Remember, we got 66 seconds for the first trip, but now the breaker is warmer than it was in the first test. You see, it's now 37. So it's very close to half the time we got in the very first test. If we repeat again now, now the deviation will not be as large. Okay, we won't get the half of 37, I guess. Okay, very close to half that. Okay, so this takes us to a conclusion. It is before we test the actual tripping curve of a breaker, it's recommended that you submit the breaker to a nominal current during some time, okay? So it warms up to normal operating temperature, okay? If we repeat the test now, not very stable breaker, okay? Anyway, it's tripping in the left side of the curve, okay? Remember the curve, okay? We are testing here. So we are getting a large amount of time. I mean, it's quite in a very vertical section of the curve. If you apply a tolerance here, I mean, if you extend a band of tolerance at both sides of the curve, the value in terms of time will go up very quickly and will go down very quickly, which will not happen in this side of the curve. Okay, in this side of the curve, distant values of current will produce very near values of trip time here. Okay, but in the very beginning of the curve, you have to expect differences in the trip time. All right. So let's go to the second test value, which is 500 ampere. Okay. We are going to select now a different adjustment range. Just double click here. We go to a different adjustment range because we have a limit of 500 ampere here. So I'm going to a slightly larger range. For the new range, I need to recalibrate the load. Okay, so I enter a small amount of 100 ampere. I reclose the breaker and recalibrate the load for a while. That's it. Now I adjust the actual test value, which is 500 ampere, and press on. So you see the chronometer also running here. Okay, we are now tripping at around 8 seconds. Okay, let's repeat. It's obvious that the amount of heat produced at 500 ampere is sensibly higher. Okay, let's repeat again. Okay, we are now getting steady values around 3 seconds for 500. Next value we had 800. Okay, so I will adjust 800 here now. And start. Okay, you have possibly heard the starting of the magnetic element in this breaker. Also, the trip time is not magnetic. Okay, this is a thermal trip time. Magnetic time is much smaller, a few tens or hundreds of milliseconds. Okay, this is still in the thermal section of the curve. Okay, let's try again. Okay, you see approximately the same time here. Okay, and let's go to 900. 900 is supposedly, let's check the curve again, well inside the magnetic section. Okay, so let's try there. Close it again and try to 900. Now we are going to less than 1 second. Let's try now to 1000 ampere. Yeah, okay, it's steadily coming down and down and down. But still we are in the proportional section of the curve. Okay, we are not really getting a magnetic trip. Let's try with the maximum that we found in the calculator. Okay, about 1.3 kiloampere. More or less, okay, but I have heard this breaker tripping in the magnetic, and you will not hear that rattle. It's just a clack, okay, just an immediate clack with no rattle, okay. But in this case, we are not getting the same response right now from this breaker, okay. But anyway, I think that we have illustrated well the test. What I'm going to do is to show you how to save the results on the test report. Okay, we just need to press save here and just save the test, or delete the last test that I have saved in case I want to replace with this new one, or even save it with some description. Okay, for example, I can write here tripping magnetic. Of course, I can also type here on the screen. You see, on the screen keyboard, but it's more convenient to do it in the computer, so I will do it on the computer. So just save it, and that's it. Okay, so I have my results saved in the memory of the commander. The commander has an Ethernet port and also a USB port here that I can use to connect to my computer and download the results for reports. If any of you is interested on seeing again this presentation, we will publish it on the YouTube, okay, and we can provide you with a viewing link, okay. Just need to write to this address, sales@eurosmc.com. Thanks again. Goodbye to all.